Alright, welcome back guys. In this video we are discussing snake letter problem, and so what is we have given something here. And so there are some snakes and ladders. So we have a grid given snakes and ladders there. So in the image, and we have to reach here at 30 in minimum number of steps from here. We are at here currently. So this is our current position. This is our target. We have to reach here and minimum number of steps. So we can roll a dice, right? We dice can have 1, so we can reach here. At 2 we can reach here. 3, 4, 5 and 6 we can reach at these places, whatever number comes at the dice, right? So what is the minimum we can see here? So let's say we get 2, so we reach 22, then we get what from 22, 23, where we can go? So maximum, if we say maximum, what can we do? 6, 1, 2, 3, 4, 5, 6. If we get 6 from here, we go at this place, and after this, after we get 2, then we get in 3 steps we can go there. All right. Is there any way? Let's say maximum how much we get there, how much to get there? It's like 1, 2, 3, 4. If we get 4 here, first at 4, then after that we go to there. Then there's 1, 2, 3. We get 3 here. 4, 3. 2 steps. Then we got here. 1, 2, 3, 4, 4. So 3 steps also. So we can't get there less than 3 steps. So alright. What is this? Wow, it's a very good, right? This is very good. I think I will. Right. So guys, this is very good tool here. that's guys we were discussing this here. So we have uh, we have two approaches, right? Because one is BFS and one is DFS, right? In breadth first search, there is a solution given here. We can go through this and let's see what is this trying to say. First we go through this text. What is the let's say we have this first step is this: create a visited array to keep track of visited cells during the BFS traversal of the boot, right? So we have to create a visited array first. Alright, we will create visited array. Then initialize a queue that stores pair of current cell index and the number of moves taken. Then initialize a queue right. Then initialize a queue that stores pair of current cell index and number of moves taken. Right. Let's say we are storing this index. So we have to store it like that. You are at current 12, and to reach there we have taken one step, right? Like this, or say 2 steps. Alright. So, alright. Then begin from cell 0 with the distance 0. Mark it visited. So this is cell 0 here. This is cell 1. There are 30 cells with 0 to 29 here, right? Distance 0. Mark it visited and post it into the queue as starting point. While the queue is not empty, extract the front element and get its current cell and distance. Alright, we are at front and we current cell and distance we will get from there. Alright, and the current cell is the last one. The current cell is last. Then return the distance as the interpret minimum distance throws. Loop through all possible next 6 cells using a dice roll. So we go for, if we are at current, then we push next 6 cells there. Alright. Snake or ladder jump. If there is just a snake cell is not visited, mark it visited and alright, incremented by 1. Alright, so this is how it will work. Let's go through the code now. So what this code is saying is like first go through the, so what the question was saying, let's go through that. What is the input? So what is the input, guys? right, snakes and ladders. What is input given, guys? Let's see that first. Right, so try it on GFG. Here we will get the real input. So I tried to solve it first, then I am here. So let's take a look at that. Reset the code. Okay. Right. So there is a we are given a snake and ladder board, and we find the minimum number of dice throws required to reach the destination of large cell 30 cell. You are given an integer n denoting, alright. So we have given a integer n and denoting the total number of snakes and ladders. And of 2 into n, right? So the size we are 2 into I and 2 into I plus 1 values. We are given integer into the total number of snakes and ladders. Alright. So n is total snakes plus ladders, and array is given of size 2n. Alright, where 2i and 2i plus 1 values denote the starting and ending point of the respective ith snake or the ladder. Alright, so if ladder is so we have a at I position we have given a snake starting point at I plus 1, we can say 2i and 2i plus 1 also. Ladder end point similar for that ladder also. Alright, so if it is greater 2i is less than 2i plus 1, then it's a ladder, right? And if it is less, else it's a snake. Right, there are 8 right there. Assume that you have completed control over a 6-sided dice. No ladder start from cell 1. Alright, there is no ladder from first cell. So we have to first throw the at first cell our what we say our dice is a dice not the dice but our we are at 1 and we can, there is no ladder at 1, right, at cell 1. So there is a BFS given, there is DFS, though there are two approaches for that. Let's see BFS approach. We already seen the let's see the code first. So what we are doing for this is like, let's say take the main function first, right? Right, there's the code first. Let's take it. Right, so this is main function n is equal to 30, vector is given. So vector it moves n minus 1. So we are given moves vector outside n, and let's see this is 30 cells here. Alright, we have to reach that 30th position. So from 0 to 1 we have 0 index, 1 index, 2 index, 29th index, and all are initialized by 1 minus 1, right? So this is minus 1, this is minus 1, minus 1, minus 1, right? This is minus 1, all are minus 1, right? So ladders are what? Moves to 21 we have given. So there are size of alright, we have given a array also, which is 2 into 1, 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 2 this array, like this, right? We have given this array which is denoting the, we have given this input, right? We have given this input, so like so we are given this input. So this is first snake or ladder, I think, right? 2i comma 2i plus 1. These are starting and ending points. So I can be 0 to 7. So when I is equal to 0 and I is equal to 1, so 0th thing and 0 and 1 is 0 and 1. This is starting position of first ladder. Alright. So we are storing the ladders here, right? So this is a ladder from 3 to 22. So we can do it like our third position, third index in this. Let's say two second index is here, right? So this is second index, and this is second index. From second index we can go to 22 directly. So this position is similar as 22 because we have to go there, right? So we can fill it like this, right? Right. This is how what we are doing here. So 22 is index 21. So what we can do is, this is 21 now, right? And this is done. Now we have 5 to 8. 5 means fourth index to seventh index. So third, fourth, right? So we are doing this, and these things we have already. These are snakes already, alright? So if we are at 26, we have to go to 0 and move 28 is equal to 8, right? Alright? This is the main function here, alright? Then what after this is, after this what we will do, so we are calling which function after main? We are calling this function, right? Right. What is this function doing? Let's see this. Right. Alright. So we are pasting it here now, and write it. Alright, what is this doing? We have this here. right? We have this. Alright, so we have this and all are -1, but some things we have filled is with some other values which is given in this here, like 21. We don't have to take it like take these things, right? Yeah, we can delete it, right? Alright, so 1 move to which is index this is 21 now, and 4 is like 7 now, 10 is no, 4 is 7. Alright, we are doing we have given this, alright. So what we are doing here, guys, is can we take a table here, right? We have some shapes. We can draw some tables also. Given template, loop video, loop component, what? Loop component is what? Table, right? Task list, checklist, progress tracker, voting table, table only. We can take the table here. Alright, how many number of columns here? What is it? Right. Table we have given, right? Right. How many 1 2 3 4 5. All right. 1 2 3 4 and 5. Right, so we have given a table, guys. Right, so we have given a table here, this, which has 1 2 3 4 5 6, right, 6 columns here, right, 3 4 5, how many are there? 1 2 3 4, 1 is 5 here, like this, and 6th one is here, right, and 1 2 3 4 5 is like this, 1 and 2 and 3 4 and 5. All right, so we are starting from index 0 1 2 3 4 5 6 7 8, right, from now to now, wait a minute, 5 6 7 8 9 10 11 12 13 14 15 16 17 18 21 22 23 24 25 26 27 28 and 29. We have to reach here. Alright, first it's all initialized by minus 1, alright, all are initialized by minus 1. We have created this, alright, all are initialized by minus 1 here, and this is also minus 1, right, this is also, alright, alright, overall initialized by minus 1 here, right. Then we have given some array of size 2n, which n is the number of snakes plus ladders, so we have to initialize them also. So we have moved 2 is 21 here, alright, this is now 21, 4 is 7, and 10 is where? 10 can take us to 25, 19 can take us to 28, alright, 26 can take us to 0 here, and 20 can take us to 8, right, and 16 can take us to 3, this is a snake, and 18 is can take us to 6, this is also a snake, 6, right, alright. So let's call the main function, and get moves. We are passing this created array, alright. So how many moves we can go there, alright. So first we create a visited array which is all false. So minus 1, let's say we are all are false right now, alright, all are false. When it is true, we will mark as true, right. So vector boolean visited is false of size n, which is 30, and q is, we are initializing a q of vectors, alright. So we are initializing a q, right, alright. We are initializing a q, and this is a queue of vectors. Let's say this is first vector, this is second vector, like that, alright. Then visited at 0 is true, we are passing this, which is now true, and this is true also, and we are pushing it vector is 0 0, which we are moving, we are at this initial position, and it takes us 0, like 0 moves, so 0 comma 0 is are there, alright. So while q is not empty, q is front, current is like this, we are at vertex is 0, we are at 0 vertex, and distance is 0 also, alright. Now check like v is equal to n minus 1 if vertex is n minus 1, if we have reached there, which is north, so we have to return the distance. If it is north, then q dot pop. Now we have to take next 6 what positions from which where we can go. So let's say we are at plus v, j is v plus 1, which is this 1, and v 0 v is equal to 0 right now, alright, v is equal to 0, so 0 plus 1 is 1. Let's check this, and v j is less than n, yes, j is less than n, so right, because we have to be under the boundary, and if visited is not visited, which is true, and visited is now make it true also, alright. And now in the destination, move the destination cell if there is a ladder or snake, alright, int destination is equal to move j is not equal to -1. If it is not -1, which it is -1, then destination would be like move j, alright, else j, alright, else it is j, right, correct. Then push that, and we have to check for 2 also, so we have to push only this is popped, right, this is popped, so we can take this and we can push the new element, which is 1 comma 1 here, j is 1, and we can check 2, then we can take it like move is 2 1, and current we can go to 21, right, 21 comma 2 3 like this, 3 comma 1 and 7 comma 1 and like this, and then we go from here, we go from here, alright. So this is not very hard solution to solve. We can solve this. So let's just code now with the VFS. So we have something given, and we have n, we have array, alright. Then what we have? So we have to create, we have given a array, so we have to create a vector of size n, vector of integers, which we can move, or we can say grid also, but we can say moves, which equal to n comma, which is initialized to -1 here, right. We can have a visited, right. Right, it's we can have a cell of visited. So if it is not visited, so one more thing we have to check, like we are checking the minimum thing, right, distance, alright. So first whoever will move, then it will, alright, it will automatically give the minimum to us, right. So destination over here, right, destination -1, right. So alright, so alright. We have some visited array, which will wait a minute. Visited, which is all false. Now we have to modify this according to the what we have given in the letters, so we can modify that also. Alright, we can modify the cynical ladder, so we can go like n, we have given n, so for int I is equal to 0, I is less than n, I plus plus, so 2i and 2i plus 1, so at moves of right, 2i, right, no, yes, 2i minus 1, I, because index starts from that position, so moves of 2 into I minus 1 equal to moves into 2 into I, wait a minute, right, because like Because we have given an array of size, let's say 2 of 8, and we have 3 to 22, right? Like 3 to 20. So because this is 0 index, 1 index, 2 index, so moves of 2 into I minus 1, 2i like 0th, which is 3, 2i, right? 2i would be, right, so we have to go for array 2i, right? Array of 2i, and right. No. So array of I will give us 3 or 0 and right. What? Alright, so I and I plus 1. Right, so there are 4 snake and ladders. We have 8 positions. First is that, and so ith value will take us to I plus 1th value, right? Right. So right, so nth I value will take us to, let's say 0, it will give minus 1, that is equal to I plus 1 minus 1. Right, so let's say it will give us ARRR I, which will give us 3. We put it into in our index 1, right? And what value will we put in this? It's like I plus 1 minus 1. Right. This is good. This is initialized with good intentions, and right. Now what we do? We create a queue of pair, QUEUE, of pair and which is Q, and now we are at index 0. So widgeted of 0 is equal to true and 0 cell, and what we are doing, let's say widgeted is 0 true, then q dot push, what we will push here is like we are at 0 cell with 0 distance, and now what we do, while q is not empty, right, while key is not empty, we first take the first element from that, to current cell the distance equal to q dot front. Wait a minute, no. Auto cell is equal to q dot front, and we saw and current is equal to cell dot first, and distance is equal to cell dot second, right. So minus 1, why we put here, like to indicate that if it is a snake cell ladder or just a normal cell, right, like that. So we now check for next 6 cells. So if right, current is equal to n minus 1, then return distance. If it is we have not reached there, then what we do is go from here, then for int I equal to 0, I is no j is equal to current plus 1 comma and j is less than equal to, right? Current plus 6, right? And j is less than, and also j plus plus, this will be here, and one with current less than, right? Less than is equal, not the equal to 1. Alright. So now we check if it is widgeted or not, right? If not widgeted j, then what will we do? We make it widgeted first. We make it widgeted first, which is j is equal to true. And how we push this, right? How we push? Is there any better trick? We have. I have also one trick, but let's check if we are. The destination is new now here. Outline. Alright. We define a new destination here in this scope. And the destination is equal to if moves j is not equal to -1, then we take it as not equal to moves j, else j, right? And now we push q dot push, which is like current is j comma destination right, destination. How we are calculating the destination, alright, which is alright. So dest distance plus 1, right? Dest comma distance. We are returning distance there, right? If it does not return anything, then we can return -1. Sure. So it's a big N, right? It's a big N. We can do this. We can do this modification, right? And n is equal to n. Both n will work now. That right. If why we are putting if there, next we don't need to put if here, right? Again, this is runtime error, right? Why this runtime error comes? Let's see why this error comes. Alright, let's check why this error comes. Also, heap corruption, let's remember corruption key, memory manager, log maintenance, some function, when the memory manager later tries to legal free memory, common causes. Alright, where it is then? Why we are getting this error, guys? Do we have any clue? Visited, where is our visited and false? It is not. Moves print and commas 1, all form slash. Moves, alright, moves and n. No, n is not like that. N, alright, so moves it's 30, right? Alright, so moves is of size 30, right? What is n given us? Let's take a look at this. 30 only. It's 30, guys. It's equal to 30, guys. 30. For that, we are can go for n. We are here n. Alright. Visitor also I am using n. You can go like this. Right. Your output is 0, expected output 3. What is the problem in this now? Let's check, right. V plus less than plus V plus j. First to thing. I think I'm doing right things here. Just one thing is left here, just like this. So I'm making a balloon. A distance plus 1, right, guys? We have to do this right. Oh, it's going right. I only took this past, right? Oh, okay. We're doing great here. I think it's going good, but I don't know what is the problem here, guys. Right, I plus equal to 2, right. You have to less equal to 2. So what is the difference between this code? Then Alright, we have done the DFS thing. Now we will check the DFS question also, like how this works, right? So what we are doing in this, right? Right, whatever it is. Right. So how DFS is working, right? What is the approach of DFS here? So DFS we have see already. So what DFS is doing is like so what it is doing is idea of explore all possible dice throws using depth first search to explore every path from start to finish. Through process, it is to move the from current position to all possible next positions via dash through 1 to 6, jumping to a new location if there is a snake or ladder. Right. So an important observation is to prune paths that are already worse than. Prune means what? Search Google for prune. Prune means for cut it, stop it, right? You can see the meaning from the context here, like prune the path. We have already passed than the previous found using the visual map that track minimum moves at each cell, so we have to create a map also, so which will track the number of visited paths, right? That tracks minimum which map that minimum number of moves at each cell. This ensures we pursue your paths and stop every when shorter ones is already found. Alright. Step 2 implements the above idea. Define a recursive function that explores all possible paths from current position with move counter. Alright, so from let's say for I is equal to we are at some position, alright, position current. So what we will do, we check, we call recursive function from current to for loop. We will try I is equal to current is comma current I is less than equal to current plus 6, and we will call for that recursive function from I is equal to what the hell, a recursive function from I is equal to what? We will do the recursive function from I is equal to current plus 6, and we recursive like I, then again recursive for current plus I plus 1, then I plus 2, like that. Right, a base case to update new moves if the current path reaches the final state. Alright. Prone to recursion if the current path takes more moves than already recorded for the same position or each cell. Simulate all dice throws from one to cell and come to the next position accordingly with the next. Alright. We will see the code here first, right? Right. So this is a main which we used to initialize. Then we will get minimum dice throws. This is our function, which is DFS is a separate function, but we have a get minimum dice throws, right? This is what we are doing. We have size n, which is 30 here, and unordered map is like int visited. We take care of that, and result also. So DFS we call it 0 0 or 0 0. We will take how many moves made till now, right? Alright, visited, I mean all. Alright, what is DFS doing? Current position, then moves made till now, then vector of move, which is that main vector, and unordered map, which is keep tracking of visited and the how many moves till now. If moves made is greater than equal to rest or visited or count is current position. If our current position is there and moves made is greater than visited current position, then return from there. Alright. If current position is clear, the moves made return, and current position moves made. All the 6, next position current, for destination. Defense, alright, what, bro? It's very good. Let's take a. Should we take a break or should we do this? We should do this, right? We should do this right here. So just copy this from here, and we will try this. This is get minimum throws, right? This is our function. Right, so is given n move size, unordered map into visited, max DFS 0 move visited. Alright. Right, so what is this? Move size, map, visited, result is int max, right? So what is this denoting? Result is int max. Is this result destination, right? I don't know. Alright, so yes, distance. So we have to find minimum, so we can compare from that. We start from, this is current position, first 0 is current, second 0 is distance we have traveled to, how many moves are made till now, then for first DFS, then move, this is an array, visited, if it is visited or not, if it is visited and how many moves are there, right, and total result also. Result is total till now, what is the result here, right? Then next what we are doing is we have current position, moves made is distance here, vector is move here, alright, unordered path is there, and visited map is there, and result, alright. If moves made is greater than result, right? If we have found any result which is result is global, right? So if we have to any call of the recursive, we have found less moves than the result, then right, then this call, then we will return from that, or visited dot count, if current position is already visited, if we have, then also we will return, or and moves made, let current distance is greater, visited current position, we are coming to again at the same position, and we have less value there at current position, that position, then we will return from that, alright. Right, this is good. And if current position is n-1, then we have to return results move made, and return also from there, and visited current position is equal to moves made, so we can do this, and or next I is equal to 1 to I is equal to less than 6, and 1 is going to right, and current position plus I is less than n should be there, alright, and plus I is there, right. Then for that we have to enter next position. Next position is current position plus 1, I is 2 and 3, and destination is move. Next position is not -1. Alright, let's say it is not there, not single ladder. If it is, then like that. Right. DFS destination, which is a current will make moves made plus 1, move is direction. Alright, this is a good solution, we can try it. Alright, we can again try it with the DFS solution also, right? Okay, we have code given. Alright, we will take a vector of integer which moves n comma -1. We can take this equal to 30, and we can initialize that now that 4 and I is equal to 0, I is less than 2 into n, I plus, then moves of array I array I -1 is equal to array I plus 1 minus 1, right? And I plus is not there because 0 0 1 2 0 first second third like that. I less is equal to 2, right? So that is good. Then we take a map also. Let we take a map. Result is equal to int max. Also, result is int max, and we can take another map or ORDERED map of int this is rejected, right? Then
आप मिलते ही नहीं मतलब मैं कमा लेता हूँ कभी ना कभी। हाँ थैंक यू सो मच। कितने डालूं मतलब आपकी इच्छा हो, आपको जितने खाने हैं आप खाओ। इंदा मत हो जाना अरे नहीं खा पाओ तुम क्या पूरा डालूंगा हैं हैप्पी दिवाली यार आ गया तू? नहीं 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 मैं नहीं जा रहा यार, अब क्या करूँगा? और थोड़ा सा पढ़ाई वढ़ाई चल रही है भाई, स्नेक्स एंड लेटर्स। अरे यार इसने पूरा मैं तो 2 घंटे काट दिए, समझ में नहीं आएगा। तब भी क्या खुद से कर रहे हो क्या? पहले तो खुद से किया। हाँ बहुत ही प्रॉब्लम हो रही, फिर चैट जीपीटी करी, फिर जीएजी का सॉल्यूशन भी देखा, उससे कर रहा हूँ। सॉल्यूशन क्या मतलब? डिस्क्रिप्टिव कोड तो आना देखा होगा। कोड तो आना देखा होगा। कोड ही देखा भाई। अच्छा कोड ही देख रहे हैं? हाँ मैं कोड ही देख रहा हूँ। परेशान हो गया, इजी प्रॉब्लम है, मीडियम टाइप में है। हाँ थोड़ी है, हाँ हार्ड नहीं है वो, इतना टाइम देने की जरूरत डीएफएस तो लगाना है, जितना टाइम देना था वो दे दिया। डीएफएस से कर रहा था मैं पहले, कोड हो रहा था, थोड़ी सी दिक्कत आ गई थी। किससे कर रहे थे? डीएफएस। और ये प्रॉब्लम किसकी? दोनों से हो जाती है, होने को है ना। वो डीएफएस का डीएफएस का होगा ना, तो पता ही होगा इसमें स्नेक एंड लैडर है। कब जाएगा इंटर्नशिप पे? अगले साल है। अगले साल में होगी? अगले साल दिसंबर में। ना 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 तो? मई जो छुट्टियां थी 2 महीने की, 2 महीने की। भाई एकदम डरा के भेजा भाई मेरे को। तो डीएसए की प्रैक्टिस करना, तेरे को टाइम नहीं मिलेगा, तेरे दोस्तों को टाइम मिल जाएगा, तेरे को मिलने वाला है, ऐसा बोल के भेजा भाई। आशिमा ने आशिमा कौन? अरे एसपीसी है ना, वो इसके माइक को अपने लगी थी 2 साल। अच्छा वो पतली सी लड़की? हाँ तो फिर आने वाले
अब तो फिर रेस्ट में है फुल,
क्या?
कोई प्रेशर नहीं होगा ये
अरे नहीं यार, है यार एक्चुअली, मतलब डीएसए तो करना ही है ना यार, डीएसए नहीं है
तो
मेरा।
मतलब प्रेशर है पर वो प्रेशर नहीं होता समझ रहे
हाँ थोड़ा तो रिलैक्स रहता हूँ,
हो? समझ रहे?
थोड़ा तो रिलैक्सेशन होता है क्या, मतलब वो इंटर्नशिप का प्रेशर नहीं है बस, वो नहीं। अब जैसे हमें भाई है तो उनको तो कोई फर्क नहीं पड़ता भाई, है आदित्य भाई, हमें भाई को तो कोई फर्क नहीं पड़ता इंटर्नशिप लगे नहीं लगे, वो सोच के बैठे हैं करनी नहीं है भाई।
उसको था कि यार केसेस तो अच्छा है ही नहीं, लगने का चांस नहीं।
पापा गए थे
पापा
गए
नहीं यही है, होटल में गए हैं। अरे यहाँ आने नहीं देता यार रूम में भाई, हाँ घुसने ही नहीं देते हैं भाई हॉस्टल में। ऐसा है, वो कार्ड के सामने जो सीटें लगी हुई है ना, वो वहीं वही वही रहते देते हैं बस, उसके आगे आने ही नहीं देता। अभी अभी मैंने सैमसंग का मॉनिटर मंगाया है, तो इंस्टॉलेशन के लिए आएगा वो, है ना, तो उसको वैसे जाने चाहिए फिर वो लोग इंस्टॉलेशन वाले को।
पता नहीं भाई क्या बताऊँ।
मॉनिटर क्यों मंगाया तुमने?
अरे बड़ी स्क्रीन चाहिए यार, छोटी स्क्रीन अजीब सा लगता है, बड़ी स्क्रीन के लिए मंगाया। कीबोर्ड एकदम वो सेटअप कर रहा हूँ मैं, कीबोर्ड में मिलेगा
चेयर भी मंगा अच्छी थी
चेयर। मैं खाने से पहले ही मंगाने वाला था एक्चुअली चेयर।
तो फिर अगर तू वहाँ तो करेगा अपनी प्रैक्टिस तो तुझे ज़्यादा भी देखना पड़ेगा ना वहाँ पर।
अरे एक्चुअली पता है मेरे साथ दिक्कत है, मैं चेयर पे बैठकर आज तक काम नहीं करा यार, मैं पढ़ाई भी नहीं करी एक्चुअली। चेयर में इस बार पहली बार बैठा हूँ यहाँ पर आने के बाद, बैठकर कभी नहीं पढ़ा चेयर पर। तो मैंने बोला था पापा को कि मंगानी है, लेकिन उन्होंने कहा कि अभी इस पे बैठ के इसका आधा था, ठीक है इसका आधा था, वरना उसका आधा था नहीं।
नहीं तो तुझे टेबल चेयर है, टेबल चेयर
जेबल टेयर
बहुत खतरनाक चीज़ है,
जेबल टेयर है।
बहुत खतरनाक चीज़ है कमर के लिए। अगर आदमी इस पर ना बैठे, बेड पे बैठेगा, घर पे बैठेगा है ना, तो ज़्यादा देर एक पोजीशन में बैठ ही नहीं पाएगा, पोजीशन चेंज कर लेगा 2 मिनट में, तो उसकी प्रॉब्लम नहीं होनी कभी, समझ रहे? इस पे बैठ जाता है चुपचाप, उसको पता नहीं चलता, इस पे चुप जाता है।
अब बम तो लग जाता है मेरे को तो इस पे भाई एकदम।
ये टेबल चेयर का कौन सा है ना भाई, बस ऑफिस में भी खाते ऐसे होनी चाहिए, बैठ आराम से परिवार काम के जितना काम करो उठने वाले
किसी को नींद आ जाती है यार बेड पे बैठती,
नहीं आती,
मेरे को भी नहीं आती है नींद तो।
ये तो सब बहाने नहीं आना।
मैं बचपन से इस पे पढ़ा हूँ बेड पे ही, मैं बेड पे ही पढ़ता था, बेड पे यार नहीं तो जमीन पे। खाली खाली सा लगता क्या हमें भाई के ना, एकदम चल रहा है
शांति है,
किस वे में, अच्छे वे में बुरे वे में?
दोनों कभी मतलब शांति नहीं चाहिए होती तो कोई चाहिए, कभी शांति चाहिए होती है तो कोई नहीं चाहिए।
मेरे रूम में
अच्छे बुरे
परमानेंट शांति है,
हैं?
मेरे रूम में परमानेंट शांति है, नॉइज़ ही नहीं होता। राधा कृष्ण भाई सोते रहना भाई।
अच्छा
हाँ वो पता है, वो रात को मेरे साथ सोता है, मतलब वो जब सोता है ना तभी मैं सोता हूँ, है ना, नाइट की वजह से, है ना, मेरे को नींद आती नहीं, तो वो सो जाता है तब मैं सो जाता हूँ साथ में। वो भाई आज के तो जो 10 साढ़े 10 बजे उठता हो, है ना, कल रात को
मीडियम है क्या वो?
नहीं CS, है ना। और फिर भाई अभी फिर सुबह उठ के उसने मूवीज देखी, है ना, मूवीज देख रहा था वो कोई तो इंग्लिश मूवी, फिर वो सो गए 3 बजे समथिंग, ठीक है, और फिर वो उठे 6:30 बजे तक, 6 बजे उठे होगा, 5:30 6 बजे, ठीक है, अब वापस से बैठ कर मूवी देख रहे हैं।
अच्छा
अब रात में मूवी देखेंगे।
तो छुट्टी मिली है तो कुछ तो वो करे उसका।
मैं कहा घर बजा